Hi class, today we're going to learn about section 7.2 Similar Polygons. We have two learning targets today. The first one, be able to find unknown values using similar polygons. And the second one, be able to determine whether triangles are similar. So, solve the proportion. Remember, whenever you're solving a proportion, you need to cross multiply. So whenever you cross multiply, you're going to get that y squared is equal to 64, or 64 is equal to y squared, either one. And you take the square root of both sides and you're going to get that y is equal to 8. Similar polygons. Similar polygons are going to have the same shape but not necessarily the same size. So congruent polygons had to have the same shape and same size, but similar ones just have to be like a smaller triangle and a bigger triangle. They're going to have the same shape but not the same size. Scale factor is going to be the ratio of the lengths of the corresponding sides of the similar triangles, or the similar polygons, sorry. So for example, you could have an equilateral triangle that had all sides of 2, so 2, 2, and 2. Then you could have a triangle that was equilateral and all of the sides were 6, 6, 6, 6. The scale factor would be 2 to 6 or 1 to 3. That's what a scale factor is. The key concept for today is going to be similar polygons. So remember, they're going to have the same shape but not necessarily the same size. You can see that this one on the left is bigger than the one on the right. So two polygons are similar if and only if their corresponding angles are congruent and the corresponding side lengths are proportional. So notice A is congruent to W, B is congruent to X, C is congruent to Y, and D is congruent to Z. So the angles have to be congruent, but the sides have to be proportional. So AB over WX has to equal the same thing as BC over XY, has to equal the same thing as DC over ZY, has to equal the same thing as AD over WZ. So if we did that for each of those sides, we would always get the ratio 3 over 1. If you get the same ratio for each corresponding side, then that means that they're proportional. Right here, this is a similarity statement. So we are used to writing congruence statements. The difference is that this is the symbol for similar. It's just going to be that little curved line. That means that this figure is similar to that figure. Example 1. If triangle ABC is similar to triangle RST, list all the pairs of congruent angles and write a proportion that relates the corresponding sides. So first, let's list all the congruent angles. So using the similarity statement, I know A is congruent to R, B is congruent to S, and C is congruent to T. So the congruent angles, A is congruent to R, B is congruent to S, C is congruent to T. Now we need to write a proportion that relates the corresponding sides. So AB is going to be proportional to RS, BC is going to be proportional to ST, and AC is going to be proportional to RT. If triangle GHK is proportional to triangle PQR, determine which of the following similarity statements is not true. So is HK similar to QR? HK, QR, they're in the same spots, so this one is true. GH over PQ is equal to GK over PR. Well, that's exactly what it says up here in the similarity statement, so this one is true. K is congruent to R. K and R. They're both the third letters. That's true. Angle GHK is similar to angle QPR. See how the second one goes out of order? That means it's not similar. So your answer should be D. In similar polygons, angles are all congruent and all corresponding sides are proportional. Given that figure ABCD is similar to EFGH, complete each statement. So angle E is going to be congruent to angle A because they're both in the first positions. Angle B is going to be congruent to angle F. So this works just like a congruent statement, except it's a similarity statement. That's why it looks familiar. AB over EF equals AD over EH, because E and H are first and last, just like A and D. The second one, AD over DC is the same as EH over HG. Given LMNO is similar to QRST, find the value of each variable. So I know that LM is proportional to QR because it's in the similarity statement LMQR. I know that MN and RS are proportional, NO and ST are proportional, and LO and QT are proportional. So this is just writing out all the sides that are proportional. I know that 8 is proportional to y plus 1 because that's LM over QR. I know that 6 is proportional to 4 because that's MN over RS. And I know that X is proportional to 3 because that's NO over ST. So see how we know one of these ratios and the other two ratios have a variable? We're actually going to split this into two problems. I'm going to do 8 over y plus 1 is equal to 6 over 4. That's one problem. Then the other problem is going to be 6 over 4 is equal to x over 3. That way we can find both variables. So here's our first one. You're going to cross multiply. You'll get 32 is equal to 6y plus 6. Then we solve for y. And you're going to get that y is equal to 4 1/3. You could also leave it as 26 over 6 and then reduce it to 13 over 3. The next one, we cross multiply, we get 4x is equal to 6 times 3, so 4x is equal to 18, and x is equal to 4.5. What's the scale factor? It is the ratio of the lengths of the corresponding sides of two similar polygons. So, the scale factor for this one is going to be 6 over 4 or 3 over 2, because we want to reduce it. So it's how you go from one to the other one. That's what the scale factor is. So that would be 6 over 4, which we reduce to 3 over 2. The two polygons are similar. Find x. Well, if I'm going from the first one to the second one, I know 6 over 4 would be a ratio that I could use. And then let's see what x matches up with. It would be x over 3. So use the congruent angles to write the corresponding vertices. Oh, that's a separate question. So this is showing you what you would do to solve this problem. I just want to skip forward to the steps. Like I said, we have AB over RS, 6 over 4, is equal to CD over TU. You fill in those measurements. 6 over 4 is equal to x over 3. You're going to cross multiply. You get 18 is equal to 4x. So your answer is going to be 9 over 2 is equal to x, or you could write your answer as 4.5. So this is the problem from before. I just wanted to write out the steps for you on this slide. Alright, the polygons are similar. Solve for the variables and state the scale factor. I want you guys to try these on your own. Alright, in the first one, to find x, I know 12 matches up with 6, and then 5x plus 2 should match up with this side. This side's going to be 3x, because this is a rectangle, so opposite sides are congruent. So that's how we're going to find x. To find y, this is an angle. I know that all these angles have to be 90 since this is a rectangle. So we have 9y is equal to 90, and you'll get y is equal to 10. Then we're setting up our proportion that we just talked about. 12 over 6 is equal to 5x plus 2 over 3x. You cross multiply. You're going to get 36x is equal to 30x plus 12. We get our x's on the same side, so you get 6x is equal to 12, and then you'll get x is equal to 2. Over here, first let's find x. We're going to have 30x is equal to 120, because remember, angles are equal, so you set them equal, you don't set them proportional. So we get x is equal to 4. Now to find y, I know 9 and 6 are proportional, and then 4y plus 12 would be proportional to this side. This side's missing, but I know it's congruent to this side, so that's how we got the 20 plus 2y. You cross multiply, you're going to get 180 plus 18y is equal to 24y plus 72. And then you solve and get your answer is 18. Now we're going to determine similarity in triangles. For triangles or any polygon to be similar, they must have all pairs of angles congruent and have all corresponding sides proportional. So determine whether the triangles are similar. If they are, write a similarity statement and give the scale factor. So here's our first two triangles. So we only have the sides right now. So we would have to see if the sides are proportional. So 15 looks like it matches up with the 20. See how this is longer and this one's a little longer? So we would have to see if 15 over 20 is the same thing as 12 over 16 is the same thing as 18 over 24. That's what we want to check. So, like I said, we're matching up this side and this side, this side and this side, and then these two bottom sides. So 15 over 20 reduces to 3 over 4. 12 over 16 reduces to 3 over 4, and 18 over 24 reduces to 3 over 4. So, this gives us two answers. It tells us yes, that those sides are proportional, and it also tells you 3 over 4 is the scale factor. So, we can say that triangle QSR is similar to triangle XZY, and the scale factor is 3 over 4. Alright. Let's see if you met the target. You need to find x and y in this problem. See you in class.